All right, let's go on 42. All right, so this is going on page 42 when we're done. So we are still talking about transformations, right? An important aspect of understanding functions is the concept of transformations. Throughout this course and your past courses, we've looked at functions and their graphs. They can all be viewed through the perspective of transformations. Transformations will weave through everything we learn in AP Pre-Calculus. Okay, so they're not going away. We need to understand how they work and how they affect our functions. On these first two examples, it's going to be a lot like what we did last Thursday. I will tell you that these blanks are probably not big enough, and I apologize, but I can't fix it now. All right, example 1. We're going to let g be a function that is a transformation of function f, such that gives us g of x like this. We're going to describe the transformations that result with the function g. So remember, when you write these down, you want to go from left to right, because when you identify them with a graph, that's the order you need to go in. So we start by looking at this 2. Does that 2 affect x or y? Y. So that means it is a vertical something, and it is a vertical what? It is a vertical stretch. That is correct, and that is something we need to know because it's going to stretch. But what is the word that College Board wants us to use? Dilation. Very good. Vertical dilation. So we can talk about stretch, but we're going to write dilation. Dilation by what? 2. Good, because y does not lie. He's a nice guy, right? All right, so then does this 3 affect x or y? X. That means it is a horizontal something, and it is a horizontal what? What's the word for that? Translation. Good. And I told you we couldn't abbreviate it. We will abbreviate it, but put the L on it so we know it's not just meaning transformation. Horizontal translation of, now which way does this mean we go? To the right, so we're just going to put a positive 3. Because the wording that you will see from them most likely will not say left and right. It will have a positive or a negative. All right, then does this 1 affect x or y? Y. So this is a vertical translation of 1. Everybody good with that? That's old business with some kind of new wording. All right, so example 2. Let n be a function that is a transformation of function m such that we get this, and we're going to describe the transformations. All right, if I am multiplying by a negative, so I don't look at that really as a -4 as far as transformations are concerned. I've got to split those. So if I'm going to multiply by a negative, that means I have a reflection. Okay, so I'm going to reflect across. Now, does that negative sign affect x or y? Y. It affects y because it's on the outside, right? It affects y, so we reflect across what? X. Very good. Okay, so we reflect across the x-axis. Then we look at that 4. What does that affect, x or y? Y. So that is a vertical what? Dilation. Good. Dilation by 4, right? Then does that 2 affect x or y? X. And it's being multiplied, so that means it is a horizontal dilation by 1/2. Good. By 1/2, because x is a liar, right? Isn't your x a liar? That's what you want to remember. Yes. All right. We all good? Any questions at all? So that's just kind of a review of a review. If we can do that, we can do the rest. The problem comes in is when you don't think you need to take a bunch of shortcuts and then you get things all backwards. So don't be that person or those people, because there will be more than one, I'm sure. All right. So here we go. We have this graph of f of x. It consists of 2 line segments and a semicircle, and it's shown for the domain being from -3 to 5. It says to sketch a graph, and state the transformation of key points. So yes, we could just count on the graph and do those things, but you're not always going to have a graph, so we're going to kind of look at what can we do. Maybe we have a graph and we can just count and move things on there, or maybe we don't have a graph but we have ordered pairs, so we're going to kind of do it all. So let's start with what we were doing up there, and look at this, and I know that 3 affects x, right? So that means it is a horizontal translation of what? Negative 3. Very good, because we actually go to the left 3, but that is most likely how you would see it written for you. And then that 4 is going to be a vertical translation of negative 4. Now, I know that this one is super simple. I know that we just wrote 2 things down, but we could have to write 5 things down. And they're ordered from left to right, but it doesn't always group x's and y's. So once you're done, once you wrote all your stuff down, they're like, okay, so horizontal, this one affects x, this one affects y. And you just label all your x's and all your y stuff. So I know that if I start off with f and I have an ordered pair x, y, that's going to map to, well, this says for my x, the only thing that's happening with x is I'm moving to the left 3, so that has to be whatever x value it is minus 3. And then my y value, whatever y value, minus 4. Don't overthink this. Yes, x is a liar. X is a liar in function notation. When you take it out of function notation, there are no more lies. This is all the truth. We're actually going to the left. We're actually subtracting, things like that. Okay? That's why it's good to write it down, because we don't always do the opposite stuff so much as we should. All right, so then we are going to find some key points here. Now, obviously, there's an infinite amount of points. We're going to move them all, but we don't have to, think of all of them. I think if I did these 5 points, if I moved those, then I could recreate that graph. Probably not beautifully, but good enough. We agree with that? All right, so then I'm going to write down that this is for f of x, and we'll make a little t-chart of what my values are. So that first point is at negative 3, 3. Then I'm at 0, 1. Then that is 1.5, 2.5. And that's not really a guess because it's a semicircle, so it would have to be. And then 3, 1, and 5, 1. Okay. Then this would be g of x. And instead of putting x and y there, I'm going to put these 2 things there. So x minus 3 and y minus 4. So for this, negative 3, I'd do negative 3 minus 3. That would give me negative 6. Then I would do 3 minus 4, which would give me a negative 1. So that means that this point becomes this point. Then I'm going to do 0 minus 3, negative 3. 1 minus 4, negative 3. 1.5 minus 3, negative 1.5. 2.5 minus 4, negative 1.5. Everybody understand what I'm doing and where this is coming from? Okay. 3 minus 3 is 0. 1 minus 4, negative 3. 5 minus 3, 2. 1 minus 4, negative 3. So then I'm going to come over here, and I'm going to plot my new points. I'm going to go to negative 6, negative 1, negative 3, negative 3, negative 1.5, negative 1.5, 0, negative 3, 2, negative 3. Then when I redraw it, it should look the same size and shape as what you have, or as close as you can, because it's a little wonky. But if it looks like you distorted it all, then you have a point incorrect somewhere. Now, I know what some of you are thinking. Couldn't I have just started here and gone to the left 3 and down 4? Absolutely, but you won't always have a graph. Sometimes you'll just have ordered pairs. Sometimes you'll just have a function. So you gotta know how it all works together. All right? But absolutely, if it was just a graph and you were choosing graphs, go with that. That's fine. But the problem becomes that getting from here to here without doing this part sometimes doesn't come out too well for people. All right? What questions we got? We good? All right. So let's move on to this one. So this says the graph of y equals h of x has a hole at x equals 4. All right, so we've got a hole at x equals 4, consists of 3 linear line segments, or 3 linear segments. Sketch a graph of K on the same axes where we have this, and we have to state the transformations of key points. Okay, so we're going to start with this negative. So I know that that is a reflection. That is a reflection across which axis? X-axis, good. Okay, so that's the negative. Then I move on to the 2. Does that affect X or Y? X, so that is a horizontal what? Dilation of what? 1/2, good, because X is a liar. Then that 1 is going to be a vertical translation of 1. That part, hopefully, piece of cake. So then we're going to go back and label the stuff X and Y. Now, I know that this says reflect across the X-axis, but that negative affects Y, right? Horizontal dilation, that's X. Vertical translation, that's Y. So my ordered pair XY is going to map onto, so for the only thing I have X, dilation of 1/2, so it's 1/2 times X. For Y, it's a reflection, so I need that negative Y, and then plus 1. So you change the sign, then you add 1. You don't add 1 and then change the sign. Okay, the order matters there, for sure. Everybody good on that? All right, good deal. So then, let's pick our points here. I think just probably the end points, and then that random point there, because we had a hole, but there was a point down there at 4, -1, right? So that is our H. So H of X, let's make our little T-chart for that. That looks like -4, -3, -2, 1, 0, -2, 4, -1, 6, 4. It'll correct me if any of those are wrong. Let me double check that I didn't look at something wrong. Okay, everybody with me? All right, so then we're going to go to K of X. And then here's my little T-chart. I'm going to do 1/2 X and -Y plus 1. All right, so half of X, half of -4 is -2. And then -3 in here becomes a +3. And then I add 1 and I get 4. So you go ahead and fill out the rest of that. So now let's just think about what's happening here. I have a horizontal dilation, which means it's going to shrink into the center horizontally. And, okay, so you just kind of want to have an idea of what it's going to look like when it's done, because it won't look identical like it did on the last one. So I'm going to plot these points. -2, 4, -1, 0, 0, 3, 2, 2, 3, -3. All right. Do you think that there's another point that might actually be helpful for me to know where it is? What else might be helpful to know when I go to graph this, when I go to draw this in? The hole, yes. And, you know, when I left it out on purpose, but sometimes this is what happens. You go, oh, you know what? That would have been probably helpful, because once I start connecting these, I don't know where to stop. So this hole right here, oh goodness. This hole right here is at 4, 2. So I'm just going to add it to the bottom there. That's okay. Sometimes we think, oh, I should have had that too. So then this would be 2 and then -1. So 2, -1. That's where my hole is. That will kind of help me when I draw this. Because otherwise, so if I'm going to connect these two, I know that. Boop. I connect these two. Do I connect this to this? What do you think? No, I don't think so, because these two, there's the hole, and then the point that like fell out of the hole, and then that's what those are. So I'm really connecting this to the hole, and then the hole here. So you still have to have some idea of what's going on with your graph. What questions do you have? We all good? I'll take that as a yes. All right, I know some of y'all are still drawing and graphing, so I'll give you a second. All right, we good now? So the next one asks about domain and range. Now they give it to us in inequality notation, which you will be given things in inequality notation and in interval notation. However, you writing it in inequality notation, no, because it's a jungle out there when y'all start writing that stuff, because some of us don't really understand how the signs work. So on these tests, you wouldn't have to, you could write everything in interval notation, that's fine. You won't be forced to write it in this notation, but you might be forced to read it. But I would say even if I'm going to use this to write something, I think I'm going to rewrite it in interval notation first. So my domain goes from -3 to 5. And since those have lines underneath it, these are brackets. And then the range goes from 1 to 3, and these will be brackets as well. Okay? So let's do the same type of thing that we've been doing. I'm going to start here. That affects y, right? So that is a vertical dilation by what? 2. Good. And then that 3, that is a horizontal translation of what? -3. Very good. And then a vertical translation of what? -4. Good. All right, so then I'm going to, the vertical things, those are y's. This is an x. Okay. So I know then that if I have the point xy, that is going to map onto, so I have x, this would be x minus 3, and then the y, this would be 2y minus 4. Do you understand what is happening there, right? Now, when you are simply asked for domain and range, if they give you the domain and range and you can get this far, it's pretty simple, all right? All we have to do is this. My domain, now this was my original domain right here. I know for every x value, it gets shifted to the left. Excuse me. So I have to subtract 3 from all my x's, which means this is going to be -3 minus 3, which is -6. And 5 minus 3, which is 2. Sorry, my brain was going somewhere else. Because that's not an xy up there. Those are both x's. Yes? Then my range right here, my new range, I'm going to do 2 times 1, which is 2, minus 4 is a -2. And then 3 times 2 is 6, minus 4, which is 2. There's your new domain and range. Would you say that is a fairly simple question? Okay, this question was I remember this question, I was traumatized by it from the test last year. Lots of people, way too many people missed this question. And you know why they missed it? Because they didn't do this and they didn't do this. They looked at this and said, oh, I'm going to add 3 to all the domains, and then I'm going to, you see what I'm talking about? It's very easy to mess it up. Write it out so that you don't get things backwards. Okay, we're good on that? Now, You don't have to write this down, but let's say that, just stick with me for a minute. Let's say that I had an xy that mapped to x negative y. I can't even write. Okay. And we'll use that same orange domain and range. So if that happens, the domain is exactly the same, right? -3 to 5. This doesn't even change because the x didn't. The range, I would try and get -1, -3. Now, does this make sense? What's wrong with this? It's the complete opposite. It's not going in the right order, right? You have to go from least to greatest, period. I got the right numbers because I did everything correct. But if you write it down and you're not going from least to greatest, just flip it around and then you're fine, okay? But you got to flip it around. So that happens if you change the sign. You'll have it written backwards when you just do what you've been doing, but pay attention to that so that you can fix it. Okay? We okay with all that? Just think about your answers when you're done. It doesn't mean you did anything wrong. It just means you got to fix your notation. Okay? Now, the back is day 2, which will actually be day 2. We're not going to move on today. Because even though this is a lot of review stuff here, you need to practice this first before we move on to anything else. Okay? We good?